Welcome to the world of bulk nanostructured materials. Today, we will discuss about the production of bulk nanostructured materials and some important properties of these materials. Let us start from the very basic question. What are bulk nanostructured materials? The answer is bulk nanostructured materials are solids having a nano-sized microstructure, which means the basic units that make up these bulk materials will be nanoparticles. Now, the next question, what are nanoparticles? Nanoparticles are those particles whose size comes in the range of 1 nanometer to 100 nanometer. By the way, 1 nanometer is 1 billionth of a meter, that is 10 to the power minus 9 meter. We know that this is very small, but this is much bigger than atoms. Particles with nano size show some interesting properties, and we are discussing about bulk materials made of these nanoparticles. Of course, we expect some special properties for these materials also. Now, we have seen that what is meant by bulk nanostructured materials. For the sake of simplicity, these materials could be classified into two categories. The first category is called nanostructured crystals, and the second category is called disordered nanostructures. The first category is nanostructured crystals, and the second category is disordered nanostructures. Let us discuss further about these nanostructured crystals. In nanostructured crystals, the nanoparticles are arranged in a regular order, so that the lattice arrays display symmetry. So, they are characterized by the regular array of atoms, and consequently, they possess lattice arrays which show symmetry. For example, look at the picture shown. This is an ordered two-dimensional lattice of aluminium 12 nanoparticles and is qualified for the title of a nanostructured crystal. Now, let us discuss about the disordered nanostructures. In disordered nanostructures, as expected, the nanoparticles are no longer arranged in a regular order. So, the lattice arrays will not show any symmetry. So, they are characterized by no regular order of atoms, not atoms actually, but nanoparticles of nanoparticles and there is no symmetry in the lattice arrays. So, we have discussed about the disordered nanostructures and the nanostructured crystals. Look at the picture shown. This is a disordered nanostructure of aluminium 12 nanoparticles. You can differentiate it from the first picture we have shown and see that this is clearly a disordered array of nanoparticles. Let us further go into the details of the disordered nanostructures. At first, we will think about the method of synthesis of disordered nanostructures. The methods of synthesis. There are many methods for the production of disordered nanostructures. We will be discussing 4 methods. We will be limiting our discussion to actually 4 methods. And these 4 methods are: 1. Compaction and consolidation. The second method is rapid solidification. The third one is gas atomization. And finally, comes the method electro deposition. Let us start from the first method, compaction and consolidation. Compaction and consolidation is an important method for the preparation of disordered nanostructures. For example, let us consider the making of copper iron alloys. The production of copper iron alloys. There are 3 phases for the preparation of copper iron alloys in compaction and consolidation method. In the first phase, the powdered copper and iron having the composition iron 85 and copper 15. Iron 85, copper 15 is ball milled for about 15 hours. So, this is the first phase. In phase 1, iron 85, copper 15 powders are ball milled for 15 hours and we get fine powders, and this is done at room temperature. Then in the second phase, the material is put in a tungsten carbide die. In the second phase, actually phase 2, materials is put in a tungsten carbide die and compacted at a pressure of 1 gigapascal for 24 hours. 1 GPa, which is 1 into 10 to the power 9 Pascal for 24 hours for a full day. Then comes the third phase. This is called the hot compaction phase. the compact which we have taken from, which we obtained from phase 2 is taken into hot compaction in phase 3, and the material is hot compacted for 30 minutes at a temperature of 400 degrees Celsius and at a pressure of 870 megapascal. So, hot compaction is done at a temperature of 400 degrees Celsius and at a pressure of 870 megapascal, which is 870 into 10 to the power 6 Pascal for about 30 minutes. Now, our alloy is ready. After the 3 phases, the density of the resulting compact is 99.2% of the maximum possible density. Mind you, 99.2% of the maximum possible density that the copper iron alloy can possess. Look at the figure. This is a bar diagram showing the size of the particles against their percentage distribution that we have obtained from the synthesis. It is seen that the largest fraction of particles is having a grain size of about 40 nanometer in a range of 20 nanometer to 70 nanometer. We can study the elastic properties of the obtained material from the stress strain curve of the compact as shown in the figure. The elastic properties. Elastic properties are studied from the stress strain curve. In the curve, there is a ductile region which represents an elongation before fracture. The fracture occurs at 2.8 gigapascal, which is about 5 times the fracture stress of iron with grain size 50 to 150 micron. That is our normal iron. Hence, making materials with nano-sized grains will result in significant increase in yield stress. Increased yield stress and can be used to make stronger materials, say for example, automobile bodies. Now, let us look at the second method for making disordered bulk nanostructured materials. The method is called rapid solidification method. There are many ways of rapid solidification. Here we are discussing a method known as chill block melt spinning. Chill block melt spinning. Look at the picture. In this method, radio frequency heating coils or eddy current coils are used to melt a metal. We know that when a radio frequency current is passed through a coil, eddy currents are generated in the metal which is placed inside the coil. This eddy current heats up the metal and melt the metal. The melt is then forced through a nozzle to form a liquid stream. This stream is continuously sprayed over the surface of a rotating metal drum under an inert gas atmosphere. This process produces thin strips of metal ranging from 10 to 100 micron thickness. The parameters that control the nanostructure of the material are the nozzle size, the melt ejection pressure, the nozzle to drum distance, and finally, the speed of rotation of the drum. These are the 4 factors that control the nanostructure of the material. This method is utilized to make lightweight and super strong aluminum alloys. In fact, more than 90% of nano aluminum alloys with other metals such as yttrium, nickel, iron are made by this method. A metal spun alloy of aluminum, yttrium, nickel, iron, consisting of 10 to 30 nanometer aluminum particles, 10 to 30 nanometer size of aluminum particles which are embedded in an amorphous matrix, can have a tensile strength more than 1.2 gigapascal. A tensile strength more than 1.2 gigapascal or more than 1.2 into 10 to the power 9 Pascal, which is amazing for a material such as aluminum. This increased strength could be attributed to the presence of defect-free aluminum nanoparticles. The reason for this strength is the presence of defect-free aluminum nanoparticles. Now, we are going to the third method for the production of bulk nanostructured materials. The third method is called gas atomization. We have seen rapid solidification method. Now, we are going to the next method, the third method called gas atomization. Look at the picture. The picture shows the arrangement for gas atomization. In this method, a high velocity inert gas such as argon is made to impact on a stream of molten metal. A fine dispersion of metal droplets is formed when the gas hits the melt. This method is used to produce large quantities of nanostructured powders, which are hot consolidated to form bulk samples. The last method that we discussed today for the preparation of disordered bulk nanostructures is electro deposition. The last method is electro deposition. Electro deposition method is used in some special cases to make nanostructured materials. For example, a nanostructured copper sheet is made by the electrolysis of copper sulfate CuSO4 solution with titanium as the negative electrode. We use titanium as the negative electrode. A copper sheet of about 2 millimeter can be formed on the titanium electrode by this method, and this will have an average grain size of 27 nanometer, 27 nanometer size copper nanoparticles and an yield strength of 119 megapascal. The yield strength goes up to 119 megapascal, 119 into 10 raised to 6 Pascal, which is normally not achieved by copper. So, we have discussed today what are bulk nanostructures, their classification as to nanostructured crystals and disordered nanostructures. And we have seen the methods of synthesis of disordered nanostructures. The methods are compaction and consolidation, rapid solidification, gas atomization, and finally, electro deposition. In the next session, we will be discussing some interesting properties of these disordered nanostructures. Till then,